Some more identities for us. We also have the Pythagorean identities. Man, well, Pythagorean theorem, as we know, a squared plus b squared equals c squared, is true for right triangles. And remember back to our good old unit circle. When we were discovering and learning about the unit circle, well, we know the radius of that circle, aka the hypotenuse of any right triangle we're creating, was 1. We know that the square of cosine plus the square of sine would have to add up to be the square of the hypotenuse. Cosine squared plus sine squared would equal 1 squared, which means they would just add up to be 1. So that is our Pythagorean identity right there. Sine squared plus cosine squared equals 1. Remember, because cosine is the x value of any point, and sine is the y value. That gives us the 2 legs. So that is our original Pythagorean identity. But from that come these other 2 identities. And before I get into all this, notice the shorthand. Instead of writing, as they say here, instead of writing sine theta squared like that, we do have a shorthand where we show it sine squared theta. It means that. It means we're squaring all that. The sine of the angle squared can be written like that. That's how you're going to see it written. So go ahead and start. Okay, all right. That's how we're going to write. That's how we're going to write the square of sine. Okay. Anyways, from this Pythagorean identity comes these other 2 very helpful Pythagorean identities. So how do we get these? Well, notice here, right here in the second one, the cosine squared of theta is a 1. Well, if we were to divide everything by cosine squared theta, theta, cosine squared theta, cosine squared theta. If we divide everything by that, well, the cosine squared has become a 1. Anything divided by itself is a 1. Sine squared theta over cosine squared theta. Sine over cosine is tangent, so that's tangent squared. And 1 over the reciprocal of cosine, well, the reciprocal of cosine is secant, so that would be secant squared. So if we know this original Pythagorean identity, we can derive that second one. And then we can get to cosine squared theta plus 1. We can also get to that, cotangent squared, because we could divide by sine squared. Divide all of these by sine squared theta. Sine squared divided by sine squared is 1. They put the 1 right there. Cosine over sine is cotangent. Cosine squared over sine squared would be cotangent squared. And 1 over sine squared is cosecant squared. So, looks like I just did exercises 69 and 70. So, that'll make those easier for you. But that is where we get those Pythagorean identities. Let's use them. Take a look at this. Okay, we're given tangent of an angle is -8. We're told that the sine of an angle happens to be greater than 0, and we want to find sine and cosine. Okay, so that's what we've got to go with. That's where we're going to start working toward. Well, just thinking about this, thinking long term. If my tangent, which remember, tangent of an angle is sine over cosine. If tangent happens to be negative and sine has to be positive, well, a positive divided by a negative gives us a negative. So just thinking long term, what we expect out of our cosine, if sine is going to be positive, cosine is going to have to be negative. It's going to have to be less than 0. So when we get these answers, that's going to help. That's certainly going to help us. So let's think about our tangent Pythagorean identity, the one with tangent. Tangent squared of our angle plus 1 You remember what that is? Tangent was when we have sine divided by cosine, so we're dividing everything by cosine, and 1 divided by cosine, the reciprocal of cosine is secant, so that'd be secant squared theta. So if you don't have it memorized, you can kind of derive it in your head knowing that sine squared plus cosine squared equals 1. That helps me. So I'm going to plug in my tangent. My tangent is -8, so this is -8 squared plus 1 equals secant squared. That's 65 equals secant squared. Take the square root of both sides. That's the square root of 65. Could be positive or negative. Equals secant. And what is secant? Secant is the reciprocal of cosine. So when I take the reciprocal of each side, the reciprocal of secant is cosine. The reciprocal of square root of 65 would be 1 over the square root of 65, which we could then rationalize and get root 65 over 65. Now it could be both positive or negative, but now we know it is cosine, and cosine must be negative. This would have to be a negative root 65 over 65 to make sure that it is going to follow everything that we've been given in a problem. So now we have cosine. We know that tangent is sine over cosine, and we know what tangent is. That's enough information to finish this problem out. -8 equals sine over cosine. Cosine is negative root 65 over 65. We know a negative times a negative gives us that positive sign that we've been expecting. And when we multiply, because we were dividing by this, we're going to have to multiply both sides by it. Negative times a negative is a positive. That would be 8 root 65 over 65 is what equals sine of theta. So we've gotten sine of theta, we've gotten cosine of theta, we have accomplished the task, and sine is positive just like they